Listen, guys. Listen here. I got something to show you all. This is real. This, this right here. Oops. Let me grab something from my Twitter. This right here is you. Maybe you're 5'11". Maybe you're 5'6". Maybe you're 4'11". Maybe you're 5'10" like I am. Or maybe you're 6'2". Whatever height you are, vaguely, this is your height. An astronaut. A human. And then we have the Hubble Space Telescope, which is about 10 times bigger, right? Let's say maybe 11 or 12 times bigger than you are. Well, let me see. Let's. Yeah, around 10 times bigger. This thing is like twice as big as that. This thing is maybe, yeah, twice as big as that. And this is a Saturn V rocket. It's a real big rocket. One of the most successful rockets that we've ever had. And this may be 1.5 times as big as the ISS, which is 10 times as big as a space shuttle, which is twice the size of a space shuttle, which is about 10 times the size of you. Like all your thoughts and feelings and all your loves and hatreds, all of that shit is about 10 times 2 times. And maybe 4. 10 times 2 times 4. 80 times as small as a space station, which is roughly, excuse me, 100 times the size, or 100, a division of 100 compared to the size of a Saturn V rocket. And then you have Bennu. Recently, we landed on Bennu. We landed on this fucking asteroid and we collected a sample from it. And it's easily, oh my, so it's like, roughly, very, very roughly, hold on, we gotta do a little math. I don't feel like doing that in my head. Roughly, so this thing is roughly ballpark 1/448th of Bennu, which is a particularly small asteroid. Remember, you are this thing, Saturn V, is like maybe a half of this, which is about a fourth of this, which is about a half of this, which is about a tenth of you. And then this thing is like, I don't know, 10 times as large as Bennu. Deimos is a moon of Mars. You know, that planet that exists. And then this thing is another asteroid, which is significantly larger than Deimos. And then Vesta. I mean, do you want me to keep doing the math? How the fuck am I going to keep doing the math? Ceres is, if I remember correctly, the moon of Pluto. Why is it labeled as a dwarf planet? Ceres. Not Ceres. Okay. So this was the first asteroid we ever detected. It's called Ceres. It's Charon. That's the moon of Pluto. Anyway, this thing is significantly larger than Vesta, which is significantly larger than Ida, significantly larger than Deimos, Bennu, Saturn V, and you. This particularly specific amount of significantly larger than you. And then Makemake is another dwarf planet. It's about a third as big as Ceres. Then we have Pluto. Pluto is a relatively small planetoid, which is roughly a third, or maybe twice as big as Makemake. Then we have Europa, which is just a random moon of Jupiter, and we have the moon. The moon. You can see that. You can see how much bigger the moon is than you. Can you? Here we are at the moon. I believe this next one is Titan. Io. Very good. Mercury. Titan. There it is. Mars. Significantly larger than the moon. Maybe about by twice as much. Can we say maybe 1.8 as much? And then Sirius B, which is a white dwarf, a particularly small star, Venus. And hey, that's our planet. Where, and let me be clear, this is our planet in comparison to the size of everything else. Where everything you have ever cared about is. Everything you love, everything you hate, all the people, all the countries, all the continents, all the shit that you've ever seen is either here on this earth or beyond it. And it is this much bigger than you. Am I making myself clear? Let's continue. Alright, so these are called super Earths. So an exoplanet is just a planet that is outside of our solar system. And we've discovered many of them. We discover them because we can see the gravitational drag that they produce on stars that are beyond our solar system. Which I remind you, this is the thing that is in our solar system that you care about. And this, Kepler 22b, and many hundreds of other exoplanets are things that you care less about because they're far away from you. Neptune is a celestial body primarily composed of gas, like hydrogen and helium, right? Uranus is the same. Then Saturn is a nice big one. Jupiter is anomalously massive and lies in the center, roughly between the Sun and the most distant planets. This is how large the Sun is compared to Jupiter, and if you can look like that is where we are. Like this right here is Earth, and then all the way down, thousands and millions of times less massive, less large than this thing, the Sun. But we're just getting started, right? The Sun is like the biggest thing we can even imagine. Do we need to remind you that this is real? This is really what we've seen in the universe? This is Sirius A. It's a very large star, relatively nearby to us. And this displays to us the distribution of matter being isotropic, right? There are relatively large stars near us, and there are relatively meager stars next to us. And then we get to something like Pollux, which is quite large indeed. It's a red giant. And then Sagittarius A star, which is the black hole at the center of our galaxy. And I'm sure you, whoever you are, don't quite understand just how massive this object must be, because this thing has the least volume per mass as any object can possibly have. That's what a black hole really is. It has the most mass per volume, which means that the size, which is dictated by volume, is the least it can be per amount of matter it has. So just remember that when we're looking at something like the sun, which is incredibly, ineffably, unbelievably massive compared to our little teeny tiny Earth. I mean, just look at that. Just look at how this right here. Jupiter's huge. You can't even imagine how huge Jupiter is. Look at this red spot here. There it is. There it is. That's a storm. It's about the size of Earth on Jupiter. It's unbelievably large. And then this thing, which illuminates the world and illuminates your daily life, is also unconceivably larger than that. But it keeps fucking going. Here's a star bigger than that. Here's a star even more unbelievably, unconceivably bigger than that. Here's another star. So, in this universe, it really depends on how we see it, right? Because heat, the way temperature expresses itself through the wavelengths of light, hotter things are bluer, right? It goes yellow, it goes red, and then it goes blue, and then it goes white. The hottest things, no, white and then blue. Rigel, this thing is so hot. It's hotter than the hottest girl you know of. It's so unconceivably hot, so rife with kinetic energy that you can't even fucking fathom. And again, this thing right here is the most mass you can have per volume. And yet, this thing is so much unconceivably larger than that. Maybe 6 or 7 times more voluminous than Sagittarius A star. And then this thing is even larger. Notice how it got whiter? And then this thing is even larger. And then Scooty is even larger than that. And then this black hole is... Just fucking look at it. Again, the most mass you can have per volume. This is NGC 3842. I'm sure we found it very far away from where we are. But look at how unconceivably massive it must be. This thing collected more mass. It just swept into more matter. I mean, just look where we are. It swept into so much matter that it is so much more than you and everything you cared about, and also all the things that are like before it that are so much smaller. It destroyed, like it swallowed this whole. It swallowed hundreds of those whole. It swallowed hundreds of your entire universe completely whole. And then this is Ton 618. It is, as I recall, one of the most massive objects we've ever observed. nebulae. So, what even is this, right? Like, what does this mean? These objects are gravitationally bound. So the Cat's Eye Nebula, we can call it a singular object because everything within this absurdly massive structure is gravitationally bound. Everything in this is collapsing towards the center of this Cat's Eye Nebula, which no doubt is some extremely massive galaxy with a supermassive black hole at its center. Bernard 68 is a what's called a supervoid. It's matter is lacking here. There's not a lot of matter. Maybe I don't know. Look, this shit's so fucking ridiculous. I mean, come on. This is the Crab Nebula. Who knows if it's going to coalesce together? Who even knows? These are all things we've actually seen in the universe. We see them. Yeah, this is the Milky Way galaxy. This is how large our galaxy is. And by the way, this galaxy is surrounded by light years and light years and light years and light years of just empty nothing. This is where we are, man. This is where this shit is. Right? You can think of this website as a map. All of this, maybe not all of it, but most of these objects reside within the Milky Way galaxy. For example, the Fireworks galaxy, that's elsewhere. But most of the shit that I just went over is all in this thing. What the fuck? You find other galaxies that are even larger. Andromeda is vaguely larger than us. And I mean, come the fuck on, right? The largest galaxies, which is really, that's really just a word for a set of gravitationally bound celestial objects, right? It's unconceivably larger than the Milky Way. Where you are, where Earth is. Earth is about here, I think. It's in this arm right here. And it's like in the middle, like ish here. It's I mean, are you guys having a hard time following? I'm having a hard time following. The local group is the group of galaxies that are around us. And obviously it's inconceivably larger than the galaxy itself. And even any individual galaxy, because there's so much space. There's so much space between each galaxy. And this is the Virgo supercluster. Again, this is something we call a gravitationally bound object. So something, or rather, the amalgam of the gravitational influence points towards a central area, which everything in this region is gravitating towards. And that is also true for the Laniakea supercluster. There is so much shit that it's all coalescing towards some central point of this cluster. We did the math, guys. We did the fucking math. It's all going towards the center of the Laniakea supercluster. But this thing is much further away. This thing, which is maybe 100 times larger than the culmination of all matter nearby to us, this fucking thing is like that, but it's completely far away. I can't begin to describe to you. There's literally not words for how large this thing is. I'd love to, like, oh, let's go back to the beginning, but it's too far away. It's too fucking far away. And then that thing is just this tiny little thing. So what this is displaying is something called the cosmic microwave background. The cosmic microwave background shows us the distribution of matter throughout what is called the observable universe. What the observable universe is, right? Okay, so look. There's a speed of light, right? And the universe is only so old. So all the things that we can see, like the things on the edge of this sphere, had to travel at the speed of light, which is insanely fast. Almost so fast you can't even think of how fast it is, because it's the fastest thing. All that shit had to travel from the edge of the universe to the center here, or where we are. And don't get confused. We are not the center of the universe. We're the center of our light cone, which radiates in all directions from the point of origin, which is the radius of the observable universe, where the furthest points of light have had the amount of time required to reach us. I know, it's hard to understand. Look, I get it, it's hard to understand. Who knows what's past that? There's talk of an unobservable universe, or a slightly observable universe. Let's talk about gravitational lensing. There's obviously things, according to astrophysics, that are beyond this sphere. Again, let's remember where we started. Right in here. Right there. Where you're looking out as a humble individual of the human race. This shit all exists around you. I gotta ask you, are you gonna keep ignoring it? Look at all this. This is not make-believe. This is the real world. Who the fuck knows why?